So, officially, welcome! This is our Warsaw MuleSoft meetup. We've been offline for a couple of months, as you may notice, but we are back. Yeah, good news. And I've got more news to come to give. But today's session will be around FX streaming in Mule 4, the really useful and the topic that all we should be familiar with. Jacek will introduce the session to us, but the introduction section will be in a moment. So let's go through the agenda for today. As usual, we've got a couple of sections. The first one is introductions and community updates, what is happening in the world of MuleSoft. Then is this fully packed session with live demos that you're waiting for, so effective streaming. And at the end, we've got this quiz, usual trivia, where you can try to win vouchers for trainings from MuleSoft based on today's session. So it's nothing that you need to know from outside of Mule. Everything will be said by Jacek. So listen him carefully, and you will be probably able to win the voucher. So that's the good news. That's the good news. That's all you need is this session. So let's move on to the introduction. I will start with thanking our sponsors for partners of today's meetup, which is PwC and MuleSoft for giving out those amazing vouchers that I can give you for the trivia winners, and the PwC for the tools that I'm able to do the quiz, so you can participate in. And one thing which is not this one, and vouchers for Amazon, for Amazon.com, when you can buy goods. But more about it I will tell you in a bit. But before, as I mentioned, today's session will be covered by Jacek. Could you, Jacek, introduce yourself to us?
Yes, sure. My name is Jacek. I work for Roche company for I think 12 years already. Currently, I'm mostly involved in integration technologies related to the MuleSoft, which is one of our, I would say, leading platform in this area. Previously, I used to work a lot with Salesforce platform for a couple of years also. Yeah, I will be your presenter for today. Thank you.
And as you said, as we talked about at the beginning, you got a lot of certification from MuleSoft, couple of, and you've won a couple of vouchers, yeah? So you can say that it's worth attending our meetups. I hope yes.
Yes, I agree. Yeah, actually, I won one voucher one time.
Okay. Oh, I thought that it was twice, but one is good enough as well. But I think that we've got someone that won twice or something like this. Let's see. Let's move on. Thanks for this neat introduction, Jacek. As well, I will introduce myself for the ones who do not know me. I am MuleSoft meetup leader for our Warsaw group. I'm also one of the MuleSoft ambassadors. In PwC, I'm integration subject matter expert. I'm worked with MuleSoft for many years right now. With a variety of different kind of deployments, different architectures. So it was quite a lot now, but still learning new products as they are released. Nevertheless, I've been in the MuleSoft for a long time, digging deeply. Yeah, let's say it. And of course, I'm writing blog posts on my ambassadorpatrick.com webpage. And as this is Meetup, I encourage you, to hashtag on your LinkedIn profile. Maybe someone else can join, as still registration is open. The tough session is still in front of us. Just tweet on it. It will be much appreciated. And as I said at the beginning, there is sponsored by PwC free Amazon vouchers for $40. So you can buy some books, IT books or whatever. Especially I like books from Amazon, but the IT ebooks that I can download. But whatever suits you. Nevertheless, I will randomly pick this. I will select randomly person that does not include me or Jacek, unfortunately. And this is random, so you do not need to nothing. Just be here, as this is. I will be picking this just only from people that are attending and are online at the moment that I will that the person will be picked. If you won't be there, you won't have it. Just as simple as that. And after it, I will send direct message to that person, just giving me the details like email address when I can send the voucher that you can use later on. Okay, I think this is plain and simple. And did I say that it will be scattered across the event? So in some moment, I will interrupt Jacek in his amazing presentation and say, wait a moment, we've got a voucher to give. And yeah, amazing part will happen. Okay, let's go through the community updates. As you know, soon will be happening TEDx 22 conference. This is a new kind of conference when the MuleSoft will be together with Salesforce, Tableau, and etc. This is purely for developers. It's some new approach to community events. Likewise, Connect will be more less developer oriented, by more business oriented. So TEDx is definitely for you. It's happening next month, 27, 28 in San Francisco. Of course, there will be happening loads of sessions. I already saw what's happening there. You can, of course, visit the webpage of this event and see it for yourself. You can pick from variety of areas, as I said, for example, like Salesforce, Tableau, MuleSoft, and pick whatever session suits you best. What is more, you will be able, you will hear their new updates from the MuleSoft products that I think we all are eager to hear and see. Actually, as many of them, we will see a couple of betas that will appear of new products. I saw a couple of them already, but we are still waiting for official release. So you need just to attend it online or in place to see it for yourself. And those of you who are joining them in person, just ping me on direct message. I will be there too, so it will be good to meet in place in San Francisco on the TEDx. Even more, I'm doing one of the sessions about serverless. I needed to tell it about serverless Lambda services via MuleSoft platform. Yeah, so that's one of the biggest updates that I've got. And we've got, of course, apart from these local meetups that are happening all over the world, still in a COVID restrictions, so most of them are online. So you can pick whatever topic suits you in different places over the world. You can see upcoming MuleSoft meetups on the MuleSoft meetup page. Here I post the link when I share the presentation. You can just click it or just Google it and you will see it. What do you pick? We've got even today's event. Apart from this, you can follow Mariana Lemos from MuleSoft. On her profile, she posts weekly infos about them in meetups, so you can as well be notified about something you will, and something will be interesting for you. And about apart from this, the meetups are shared on MuleSoft community LinkedIn group. And if you are not member of this yet, just join it. There is this is the official MuleSoft community channel that is waiting for you. Okay, that's all from the community. No, there is one. The next Warsaw MuleSoft meetup will happen on site, so we'll be meeting in person. I hope that you will find this information well, as I am always eager to talk with you face to face and got the networking in the breaks. That's what we are just unfortunately missing during those online sessions. But yeah, let's give it a try to meet in person. And without yeah, we can go straight to Jacek part. I will stop sharing my screen. Oh, as I see that there are people can talk. Anyone have a questions around the community updates, or we are deeping dive into Jacek's session? No, Jacek, feel free to share your screen. Give us this good piece of experience of yours.
We'll see. We'll see.
Oh yeah, I saw what you've
Okay.
got there.
I will make a full screen. Can you see it? Can you see my screen?
Yes.
Okay. Okay. So again, welcome everyone to today's session. The main topic for today will be streaming, effective streaming in Mule 4. I will be talking first about the about streams as a general concept. Then I will be also talking about different types of streaming available in Mule 4. What are the pros and cons of different designs? And I believe that this is the info that is valuable for developers and architects to make good architectural decisions. How to really efficiently process large input data, and what is also important, to control the memory consumption. It is an important factor I will be talking about. So the agenda for today's meeting is, like I said, introduction to streams, then streams in Mule specifically, then will be the first demo. I will be showing streaming in action. And then I think would be the most advanced part of this demonstration is the streaming in data weave. It is maybe advanced, but still a very useful mechanism, which allows us to build the whole chains of processors and to process data in stream efficiently. So this will be my second demo will be about it. And finally, there will be a summary and some performance considerations at the end, some comments and maybe advices. So let's go to the first chapter, which is about the streams as a concept. But to introduce it, I will start with some general, I would say, integration challenge. Very, very general. I mean, usually a middleware like MuleSoft is used for the application like reading the data from the source. And there might be a variety of different sources, database, file. It might be also an HTTP request, of course, this is very common. Then to process it, and then move it forward to the destination, which might be, again, database, file, and HTTP response. is also possible. So if the data coming to the middleware is of low volume, it is such a processing is trivial. So we can do the simplest way available, so to read the whole data into memory and process it. It's not a problem because the volume is low. The issue might arise if, for some reason, there must be also a variety of reasons, some unpredictable behavior of the source or something, the volume becomes large. Of course, it is a very relative thing, what it means large, but large in terms of volume, in terms of frequency of requests, of the number of requests at the same time. So we might, so having this simple way of doing, like reading the whole input data to the memory and to process it further, we might exceed the memory heap. Of course, it ends up with the out of memory error. It is a general, I would say, challenge. So how can we deal with that? Because there are, of course, many ways. Yeah, I will just name a few of them, and streaming is just one of them. Yeah, it's not the only one. So this way, which is now on the screen, is also very, I would say, basic, but still relatively common, I would say. So when we are, for example, processing large files, which can be easily splitted, because these files are, for example, comma-separated values, then we can use some external use. It may be, I don't know, custom-made, even some simple Java program to divide the large file into smaller parts, and then iteratively we can read the files, having or being sure that the size of the file, the size of files, is below some acceptable limit. So we can safely read it into memory, process, and clean the memory, push it forward. Yeah? This is one of the ways. Might be useful for some cases. The other thing, which is also quite common nowadays, is paging or pagination. Yeah. There are some APIs. One of them is OData protocol, which support paging. So usually we are, for such APIs, there are usually parameters. Okay, of course, they have different names, but generally the concept is the same. So we have offset and limit. So we are starting from some point, not necessarily from the beginning, and we're taking just a chunk of data, and the next chunk, and the next chunk. We are moving through the data, and this also saves us from unwanted memory consumption. But of course, it requires some special support from the source, which for this case is paging. And we can also think about something like a stream. It is a very popular concept in Java world in general, also in other technologies, of course. The stream is like a pointer to the data. So instead of reading the whole data into memory at once, we are just creating something like a cursor, maybe a pointer cursor anyway, something that points to the beginning of the data. Usually such a cursor is then encapsulated in object to treat it as an object, and this object is called stream. So with this approach, data is being read constantly from the source, is being processed on the fly, and then redirected to the destination. But in every single moment of time, the number of data being processed is low or very low. So the data is flowing through the middleware. And it came to my mind that it could be a good analogy just from the geography. Might be funny, but it is actually a very good analogy to what we presented on the previous slide. Let's imagine that we have a stream, like in mountains. It starts somewhere in a very distant place in mountains, and it flows. And let's imagine that there is a guy here with a spoon, and the guy is steering the water with this spoon. This is the analogy of the data processor. The guy processes the water, and processed water then flows away down the stream. So in every single moment, the guy / processor has access to only a small amount of water being processed. What are the limitations? The limitations are that processed water cannot be processed more than one time. It's already processed, it's gone. Yeah? And sitting in this place, we cannot do a jump or skip here and take this water. We need to wait until all of it is processed, and then we can process this fragment of the stream. Yeah? So this is very similar to what we showed here. Good analogy. So this is the stream in general. How does the support in Mule4 looks like for streams? Basically, in MuleSoft 4, we have 3 different types of streams. One of it, which is called the non-repeatable stream, was available also in the previous version of the MuleSoft. It was available in the Mule 3, for example. Those 2 are new. I mean, in-memory repeatable stream, file stored repeatable stream are new to the Mule 4. They are very interesting. I will be, of course, talking about them in the next slides. So let's start with this non-repeatable stream. The non-repeatable stream, and this name is important, is the stream that behaves like this geographical stream. I mean, this is the stream that can be read from the source, can be processed just once. This is one of the main limitations for this stream. It cannot be read many times, because if a given chunk of data is processed, it's gone. It's been pushed to the destination or to the further processing. We cannot process it again. This is the first thing. The second is that such kind of a stream cannot be consumed simultaneously by many threads. It cannot be shared. It can be processed just by the one thread. This kind of stream has also its strengths, because it's very performant. Also because it does not involve any additional memory buffers and I/O operations. I would be talking about it later on, but for the time being, let's notice that this is quite a performant way of processing data, but still having in mind all of the limitations related. On this screen, we have some screenshots taken from the Mule, and they demonstrate this first limitation, that this kind of stream, non-repeatable stream, cannot be read more than once. If we have a source, which is for this case is a HTTP listener, and we have 2 processors, one and next to it the next one, both write file. Okay, this one will work. It will write the content to the file. This one will not work because the stream has been already consumed. So this is not okay approach for this non-repeatable stream. A similar situation, but not that obvious, is here. it looks quite innocent. We have a listener, we have a non-repeatable stream being read, we have some transfer message which actually consumes the stream, and we have a logger, but this logger is not like the static logger that, I don't know, prints a string end or finished or something, but it tries to write, for example, size of payload. This is not possible because we don't have this payload anymore. It's been consumed in this processor, so it cannot be done. This is the limitation. And similar thing, a similar screenshot for this second limitation. Cannot be this kind of stream cannot be consumed simultaneously. If we, for example, use scatter-gather component, which spins up several threads, and each thread tries to consume the stream, it is not possible for this kind of stream. Okay, this was the simplest one. There are two new streams available in Mule 4. Both of them are repeatable streams. This is important because this is an attempt coming from MuleSoft to make developers' life easier and to ensure or to maybe to overcome those limitations involved with non-repeatable streams. Those two. So to allow the stream to be read many times and to allow it to be processed simultaneously by many threads. So MuleSoft encapsulates the input stream with additional, let's call it logic. So apart from just an input stream, simple input stream that reads the data from the source, we have a buffer in memory. This complexity is of course hidden from us, so it's being done implicitly when we are using this kind of a stream. The data is buffered in memory, and then once it's been read to the buffer, it's then also it can be consumed many times, but the data is read from the buffer. So this is the reason why it can be read many times. When we use this kind of a stream for the source, and again, in MuleSoft, there are many sources that support streaming. It might be database, file, SFTP, HTTP listener, many. So if we choose the repeatable in-memory stream, we have a couple of parameters we can define. These are defaults. I will just shortly tell about them to let you understand the mechanics here. So, and let's start from the bottom. We have the buffer unit at the beginning, which might be kilobytes, megabytes, even gigabytes. So we are selecting the unit in which we will be measuring the data volume. And then again, from the beginning, initial buffer size. It is the size of the buffer that is being created at the beginning when the data is read for the first time. So by default, it will be 512 kilobytes. If this amount of memory is enough to read the whole stream, that's okay. That's the end. If not, if we need more memory, then the buffer is increased by this size increment. So we are increasing it, but additional 512 kilobytes. And we will be doing it, or MuleSoft will be doing it until this max buffer size is reached. So by default, this increment will happen just one time, and we will have this buffer size fulfilled. And if it's still not enough memory to read the input stream, we will have an error. No choice. Yeah, we are hitting the limit, and the only thing the MuleSoft can do right now is just to raise an error. What is, I think, the benefit of this stream is that it overcomes those limitations coming from non-repeatable streams, and it's still quick because it operates fully in memory. This kind of a stream is default for the edition of MuleSoft, which is called the community edition, and basically it's the only type of repeatable streams available for this edition. The last type is, one step more in advanced. File stored repeatable stream. It's quite similar to the in-memory repeatable stream. It's similar in a sense that it also overcomes those limitations coming from non-repeatable streams. But it also overcomes this problem with memory, I would say, limitations. Because instead of having just one buffer, this type of stream has two buffers. Number one is in memory, number two is on disk. So, and there's only one meaningful parameter apart from selecting the buffer unit. It is called in-memory size. So again, this in-memory size is 512 kilobytes, and until the data fits in this memory, no additional actions are done. But if we are exceeding this size of the buffer, then the data is stored on disk. Of course, all resources are limited, of course, but in general, disk is significantly bigger than the memory available. So we can even assume that it is almost unlimited. Yeah. So the problem with out of memory error will not appear for this kind of stream, but we need to remember about I/O operations. It might be costly for processing large files. It might be, I would say, a factor worth consideration. Yes, I don't claim by any means that it could be a problem. It's just a factor we should remember about those I/O operations. And once we have this kind of a stream, we can use many transformers. We can read many times, also in many threads simultaneously. Not a problem. This type of stream is a default one for Enterprise Edition. And I would bet that most of the developers even don't think that this particular stream is actually used in the background. It's very convenient, it's very safe, and it's from the development perspective, it does not force us to think too much about the limitations, because we have this luxury to store large data on disk and to read it back when it's needed to be processed. There is one very small detail, but I would like, okay, this might be an advanced thing and maybe very rare or seldom, but it's, I think, worth mentioning. And if we are talking about the theory, I think it's worth mentioning. Of course, the data, before it can be stored on disk, needs to be serialized. So objects stored in memory needs to be serialized. And in generally in Java world, we are doing a standard Java serializer, which requires from us to, or not from us, from the objects in memory to explicitly implement Java I/O serializable interface. And it might be considered as a limitation because there are some types of Java types that don't declare this interface, and that they automatically cannot be serialized and they cannot be stored on disk. So MuleSoft internally does not use this standard Java serializer for serializing data, but it uses a product which is called Cryo serializer, and it does better job. I mean, it can serialize even those types which don't explicitly declare that they implement Java AO serializable interface. So this is good. But even the cryo serializer has some cases, weak points, I would say. So the types that cannot be serialized. And the example of this type is XML Gregorian calendar implementation. And it is not, invented by me. This data comes from the, it's used by the NetSuite and Microsoft Dynamics CRM connectors. So it might happen that the data being read as a stream from those sources might contain this type, and there might be a problem with the serialization if there is a need for the data to be serialized, because as I said, we have some in-memory buffer, and it might happen that the serialization on disk will not be necessary at all. So this is the comment I would like to mention. This is the third and the last type. And the last slide before going to the first demo is about the stream versus iterable connectors, because it might cause some confusions at the beginning for those who start using the streaming strategies. Salesforce, sorry, not Salesforce, years of working with Salesforce. MuleSoft distinguish two types of streams, like the data stream and iterable stream. And data streams are listed here. These are like file, FTP, HTTP sockets. So this is the pure stream of bytes, no structure inside, like the stream of bytes. So the only way how we can measure the stream or to divide it into chunks is just the number of bytes. And that's the reason we have this buffer unit to be selected for this type of streams. We need to select if we want to measure in kilobytes or megabytes or something. And then we have those parameters, those three parameters. But there are also sources like database. When we are querying, we are selecting data. Or, for example, we are also querying Salesforce to retrieve objects from Salesforce. It's still a stream. I mean, the data flows from the source, but the data has its internal structure. So, for example, for databases, it would be records. For Salesforce, it would be objects. So we have already some discrete units we can measure. So there's no need to define buffer unit measured in kilobytes for this type of stream, because these are like objects or records. The whole mechanics is exactly the same. So we have the initial buffer size, we have this size increment, which this initial buffer size is not enough. And we have also max in-memory instances. And if we exceed this value, then we have this out-of-memory error. But we don't need to specify the buffer unit measured in kilobytes because we have objects or records here. This is, I think, an important comment worth mentioning, just to avoid confusion. Okay. This is the first part of the theory. Theory is interesting, but the practice is more interesting. So let's go.
I've got one question, Jacek. Okay. Can we just have a little simple, quick break? I'd like to give one voucher for Amazon in bit before people will see this amazing demo that will explain the stuff. Let me just. I've got all the attendees that are logged in today, so from this list are selected. Let me just generate number. How many people we have?
Should I stop sharing?
Can you for a moment?
Yeah.
Okay. Just to clarify that it's fair I do not make made values from my mind. So we've got 77, 76 as one row is. Here's the number. Here are the people attending today. Checked in at least, and I'm using this kind of tool. 70. I wrote 76. Of course, we may be on this track, Kuba, but Kuba, Jacek, but I will eliminate us. 25. So let me quickly eliminate the list. 25. Who is it? Higawit Robinson. Congrats, you've won the Amazon voucher. I will hit you directly. Hit you. I will will send you direct message. Congrats, you won the $30 voucher for Amazon, Amazon.com. Yay! Okay, that was all. Let's move back to your amazing session. And again, congrats, Higawit. Sorry if I will pronounce it incorrectly. Yay!
Okay.
Yay! Start sharing.
Okay. Mhm. Okay, it's frozen right now. Just a moment.
Did I break your PC? I hope not. And
I
before
need to wait
session.
for them. No, there will be a session. But it doesn't, the sharing does not work. Maybe
but you
I
can
need
click
to reconnect
start
now.
sharing. But you can click share
Yes,
screen.
yes, but it's the whole screen is frozen. Yeah, the Chrome is not responding. I think I need
Okay.
to reconnect.
Okay, sure.
Okay.
We'll wait a minute. In the meantime,
Mhm.
when Jacek will be reattending, I will just roll the congrats. Mhm. I hope you are enjoying session so far. I hear nothing, no one against, so I expect you enjoy.
Yeah, it's fine. I guess everyone is checking the Amazon offer currently. Maybe that's why the PC froze and internet issues. $30, you know. Better to be prepared.
I'm back. Can you hear me?
Yes, we can hear you. Can you try share your screen again?
Yeah, just a moment. It should work right
It
now.
works. Yeah, I can see it.
Okay. So sorry for this technical problem. Can you see my Endpoint Studio?
Yeah.
Okay. Okay, that's good. So for the first demo, I will show you two very simple flows to show two different types of streams in action. There will be those two flows will be almost the same with just one difference, and the difference will be the type of stream which is used. So there will be streaming demo 1, streaming demo 2. And this is extremely simple because I just want to show you the, I would say, the idea, not the complex logic. So I will start. So the first element, the source, is on new or updated file. So I will be reading the file from the folder. And I defined auto delete for true. So once the file is read, the input folder will be cleared out. And then we have just a simple logger. It is a static logger, and we have a write file component, which just stores the payload to the file. Nothing more. And the final logger. So the logic is trivial, almost no logic. We are just reading the data from the input folder, and we are writing this data back to the output folder without any additional transformations. I will put a breakpoint here and also for this demo tool. And I will go to the folders. So I have a demo1 folder here on the right side with the input, which is empty, and output, which is also empty. And I have some sample records I will be using during the demos. So for the first time, I will copy to the input a very simple file, which contains, it has CSV structure and contains just one record. So we have a header and we have one record here, just for the sake of the presentation. Okay, I'm copying it to the demo1 input folder. Okay, we are here. The file has been read from the folder. What we have here, an important thing is this payload type. As you can see, this is the file input stream. Sorry, I didn't mention the most important difference. This demo1 is using, in advanced tab, is using non-repeatable stream. So this is this kind of a stream that has those two limitations. It can be read just once and cannot be processed simultaneously, but it's quite performant. For the second type of, for this second demo, everything is exactly the same, but the streaming strategy we are using is a repeatable in-memory stream with some non-default values. So the buffer unit, I used megabytes, not kilobytes, and the initial buffer size is 5 mega. Increment is also 5, and the max buffer size is 50 megabytes. For some reason, we don't want to spend more memory for one single execution than 50 megabytes. So this is the only difference between those two demos. Okay, we are here. So I would like, for example, and this is quite natural thing, what is inside? What's in the payload? I cannot read it. Why? Because this is the stream. This stream has not been yet consumed. It's just open. So we are at the beginning. We are pointing to the beginning of the data, but we don't know at this moment what the data is. This is the nature of this regular non-repeatable stream. We can go deeper and we can see the parameter closed, false. It's still open. Okay, I'm moving to the right operation. It's still input stream. Okay, it's been written. Now it's still a stream in the payload, but it is closed already. You can see closed true. So if I had, hypothetically, if I had some additional processor here, like message transfer or additional write or anything that tries to read the payload, I would end with the error because this stream has been already consumed. Okay, I'm letting this flow goes, and the input folder is empty. Output folder contains this file. Nothing changes. Only the name of the file is different because it is hard coded, but the content is the same. Okay, let's go to the demo tool and copy this small file with just one record inside. Okay, we stopped in this logger. The source is already behind us, and what we can see as a payload, you can see the difference. We can see the content of the stream. Why? We thought that we are using streams, but internally, MuleSoft already created a memory buffer. So the data is already in this buffer. This stream basically has been already consumed. I mean, the data is already inside the RAM in the MuleSoft runtime, and that's the reason why we can see it. We can process it many times. We can also process it simultaneously. So this is that's the reason. Okay, we can go now to the next step and finish it. So the result is basically the same. The output is that the input folder is empty, output folder contains. So I would say the business logic is the same, but the internal mechanism that was used to process those two demos was different. And now let's see that it would be an interesting exercise. Let's see what is the impact of those two approaches on the memory consumption. To check it, we will use the tool which is called Visual VM. It is quite popular tool. It's freely available on GitHub. You can just download the version which is suitable for you for many platforms because it's of course Java based. So we will use Visual VM to see how the memory is being consumed internally by the MuleSoft runtime. How we can check it? We have a list of all JVMs being active now on my laptop, and all of them have those PIDs here. So to be sure what PID we should PID we should use, let's go to the console. I cleared it up. Sorry. Okay, at the beginning, when the MuleSoft runtime starts, there is this information is displayed. So now I don't know precisely which is, but this will be probably this one. Okay. It's MuleSoft informs what PID is being used when it starts. Okay, I will close the threads and classes just to focus on the memory and CPU usage. The memory usage is now on the static level because nothing happens basically. So let's move to the input for the demo one, but to start it, I will remove breakpoints because I don't want to stop the processing again in the middle. So again, I will use this file. It contains 200,000 records in the CSV file. Not too much. It's like 25 megabytes of data, so it is not very big file. I will copy it to the input folder. Okay, let's see the behavior. Okay, I will go to the console. Okay, start, stop, folder input. Yeah, it's empty. Output 25 megabytes. Impact on memory, nothing. The data just flew through the MuleSoft like like a blizzard, and without any significant impact on memory consumption. Let's now do the second demonstration. This will be demo number 2. Demo number 2 is the one that uses in-memory repeatable stream. So the memory buffer is involved. I'm copying the data here. Look at this. You can see the immediate effect on the memory consumption. I will go to the start, stop. Okay, it's been processed.
Sorry, was it like 300 megabytes? Did I saw it correctly?
Yes. I would
Intensive.
I would not look very carefully to the specific number. I just want to emphasize the I would say the mechanics. Internally, there might be some differences. I don't know. Maybe it needs to MuleSoft reserve some more memory for internal purposes. I don't know, but the important effect is that the in-memory buffer has been created, and it has immediate effect on the memory consumption. What is now the threat that might happen? I will show you. Let's assume that we have a contract with an external company, and we are expected to process the data they are provided, and in the contract there is a limit that the data should not contain more than 200,000 records. But after some weekend or after some data peak or something, we received 1 million. So it's 124 megabytes as a CSV file. Okay, I'm copying it. What happens? First of all, I'm refreshing. It's still here. Something is wrong. It hasn't been processed fully. Why? We are curious. Yeah. So let's go here. We are in the debug mode now. So every time when any error is being raised by the MuleSoft, the execution is stopped. But what is actually the root cause of this error? Let's go to the exception, internal exception, and let's look this line. Max streaming memory limit was exceeded. So what we did right now, we hit this limit, and the execution is over now. Yeah? We are on the dead end. So I don't claim that it is a problem, a general problem. It's just a situation. There are plenty of different business situations, and I'm just talking that for some cases, the fact that we have this hard limit of the memory consumption must be crucial for us, because if for some reason the amount of data we are expected to process in a given time is too much, we can end up with troubles. So this is how those streams work. So they have their strengths. I mean those repeatable streams, because they are more convenient to use, but they are still some limitations. Yes, this is what I wanted to emphasize.
May I ask one question?
Yeah, of course.
In that situation, when you got that exception casted and you are in the streaming mode, is there anything we can do? I mean, for instance, in error handling, to still save that data? I mean, or we are simply out of the options in that situation?
I think I'm not sure. Honestly, I'm not sure. From what I remember, those out of memory related errors are not probably they are not possible to handle. So it would mean that we are in the serious trouble, but I'm not actually sure, and I need to honestly say that I would need to check it if it is possible to handle this type of error or not. If not, that's very bad. Yeah, then we would need to somehow check the input or validate it, or use the different kind of stream to cover. For sure, if we used this third type of repeatable stream, which is called on disk repeatable stream, and is available for Enterprise Edition, we wouldn't have this issue, because the data would be stored on disk, and this is the default for the enterprise solution. So and it is probably the reason why it is also set as a default for this edition. Yeah. Okay, I will stop this to start fresh, and we'll go back to the theory for a moment. Yeah. Okay, I will start it, and I will switch to the presentation. Okay. Start slideshow. I need to skip a couple of slides. Sorry. Just a moment. Sorry for that, but I needed to restart my browser, and that's the reason why I now have this. Okay, this was this memory, in-memory buffer, which we now exceeded in this demo 2. Live demo, streaming in data weave. Okay, let's resume from this point. This will be the second part, as I said, maybe advanced part, but very interesting and promising in terms of building efficient solution. So I will start with the question: could we build a solution using, on one hand, non-repeatable stream, so this one which is friendly in terms of low memory consumption and no I/O operations involved, but still being able to process the data many times. So to use a couple of transformers, because usually in the real application, we need to, when we are working, we are processing the payload, we need to enhance it. We need to filter out some data. We need to, I don't know, call another systems and populate the data with additional fields, something like this. And we would like to have the possibility to use many processors, not just one, as it is normally by default possible for non-repeatable stream. By default, it can be read just once. The answer is yes, with some special treatment or some special approach. And the answer is yes, because data weave processor or processors based on data weave support end-to-end streaming and still using non-repeatable streams. This support is called deferred mode. This mode needs to be explicitly used. I will show it later on the next slide, and also in the real demo. And when we use a deferred mode for a message transform component, it instructs the component not to consume the payload or to consume the stream which is inside the payload, but only to consume a small fragment of it and then to push it through to the next processor to be consumed. So we are constituting the whole chain of processing when the next processors are processing small fragments from the stream, and it might happen that not all the data has been read yet. Some of the data is already in the destination, and the middle of the data is being processed. So this is the whole chain of processing. There are, of course, some limitations and some constraints. So this deferred mode is supported only for 3 types of input data format. 3 formats, or maybe let's see better, for 3 formats. It is CSV, it's supported for CSV documents, for JSON documents, and for XML documents. Why it is like this? For each and every type of document, it is possible to split the data when the MuleSoft knows that it deals with this type of document. He knows how to split the data into small fragments. So it's still a stream, but selected into small fragments. It is needed for this whole solution. So for the CSV document, this small fragment would be just 1 record, and then next record and next record in a stream. For JSON document, it would be, we are starting with the array of JSON objects, and we are processing object by object in this array. And for XML document, it is a little bit more complicated because we need to point explicitly, and I will also show how to do that. We need to point explicitly a fragment in an XML file that is a collection of an elements. So as you can immediately deduct, there is some iteration involved in the internal processing. So we need to show exactly the place in the structure, and the structure of the XML might be very, very complex, but there should be a place when it contains the elements next to each other, and we can iterate over them. And this is the way how we can create a stream from those elements. What is important? This stream behaves like non-repeatable stream. So when we are reading those CSV documents, JSON documents in the array, XML, we are processing small element after small element, but we cannot jump back, for example, to the element which has been already processed, because it's still a stream. So random access is not allowed. I will also show it. And this streaming is not enabled. This type or this deferred mode is not enabled by default. We have to explicitly enable it. So there are two things that needs to be done to make it working. They are very simple. The first thing, we need to instruct MuleSoft what type of data it will be dealing with, and to instruct it that it will be a stream. So if we are once we are configuring a source, for this case it is on your updated file, but it might be any other kind of a source that supports streaming. So in this advanced tab we will have a possibility to select streaming strategy. But there is also a MyMe type tab, and in this tab we have to choose one of those three supported formats. In this case it's a CSV, and we need to add additional parameter, and the name of this parameter is streaming. The value is true. This is mandatory. This is like the magic keywords that needs to be set to make it working. This is the first thing we needs to be done. And the second thing, to achieve such a behavior like this, that the transfer message does not consume the stream entirely, but it just passes it fragment by fragment as a stream to the next processors, which might be another transfer messages or another processors that consume streams. In this picture, it is a write file component. So to make it working, we need to explicitly put this parameter here in the code, deferred true. This is the second factor, the second thing that needs to be configured to make it working. So again, one of those three types, and streaming true and deferred true. Once we configure it, the data flows by the transformers, not being consumed in any single transformer. Now, how the code looks like for those three types of formats. Let's focus first on the CSV. We have a very simple CSV input, like the header. We have name, last name, age, some values, and we have a script. What for sure needs to be added in the script? Of course, deferred true. This is mandatory. And in the code, it's just a regular data with code. For this case, we are mapping. So first of all, we are converting the data, yes, because the output is JSON, input was CSV, the output would be JSON. And we are processing record by record here, and we are manipulating it. We are doing some calculations, like, for example, creating full name based on last name and name, and so on. We can even skip randomly or to read randomly fields, but within a single record, because this is this small piece of information we are processing in a single time. But we cannot do something like this. Let's see on this example. We cannot do the payload -1, -2. Those pieces of payload have been already consumed. They are gone. We cannot go back in the stream. So once we did something like this, we would end up with an error. There are also some ways to save your time, save developer time, and once the code is being written or developed, to immediately know that the code you're producing is not aligned with the rules that are mandatory for this kind of streaming. I will also show it. Okay, the next type, very similar. This time we have JSON stream, so we have an array and objects in this array. And again, code very simple, exactly the same. Yeah, we have deferred true. We are also mapping record by record. And for this time, the record would be this single object. The more complex situation is in this last type of supported formats. This is the XML file. Because again, XML files are very generic, I would say. They are, you have a free hand with creating the structure. So for this simple example, we have the root element, which is order. Then we have a header, and we're interested in it the most. We have an order items element, which contains the collection of order items. That's it. This is what we would like to iterate over. So, but we need to instruct MuleSoft that this is exactly the collection it should take for the streaming. So to do it, we need additional parameter. Apart from selecting the type, which in this case is application/XML, and apart from this mandatory streaming true parameter, we have to use additional parameter, which is called collection path. And we need to point the place in the document which contains the collection of elements. So in this case, so for our example, it would be order items, going from root order items. So this is the collection that will be taken by the MuleSoft, and the rest is the same. So the code we are using in data with operates on a single record, which in this case would be this element. We have full access to this element. Last slide before going to the demo part. There is a functionality provided by MuleSoft, and it's still in the status of experimental, but it is available in the official documentation, and it is actually working. So that's the reason why I'm showing it. This is the special validator which can be added to the data with script. It is called stream capable. And once you add this validator to the code, I made it bold, stream capable, and you also need to instruct what is the type of the input. It is important for MuleSoft to know what is the type of the input, and this instruction explicitly says, please check the validity of this code, and if it's aligned to or if it obeys all of those rules. There are basically there are a couple of rules. I will not be going into details, but one of them is this obvious one, like we cannot use this negative access. We cannot go back in the stream, but there are also others. This stream capable validates all of them. If all criteria are met, the data or this script, I would say, is streamable. Otherwise, there is an error. An error during the development phase. I will show it also in action. Okay, let's move to the live demo. But maybe yeah, okay. I know. I will stop sharing.
I think this is the best place to do the suspense. This is a correct English word in Polish. I know, suspense. So let me just try to find out new Amazon voucher winner. I will just select randomly the person, number 65. So plain and simple, 65. Okay, let's click it. Yay! So the voucher for Amazon voucher goes to Shiva Krishna. Congrats, and I will directly send you a message right now for your email to send it to you the voucher. So congrats again. Yeah, and that was all. pretty quick random selection. So yeah, feel free, Jacek, to go, and in the meantime, I ping the
I will
winner.
start sharing, and I hope this time it will work.
I hope to. I hope.
Okay,
to.
it's working. It's
Nice.
not that bad. It's not that bad. Okay, okay. Let's move to the. Okay. I know what's wrong because this file is. I didn't clear it. Okay, I need to write it again. Sorry, start it again. But no problem. I will start with looking into the code. It's starting. So let's go to the streaming tree. It's similar to the previous two ones with some additional steps. I will talk about it. So we'll start from the source. Our exercise is to create the solution which uses non-repeatable streams. So in the advanced tab, we have non-repeatable stream. What we have in the MyMeType, we have this instruction that lets MuleSoft know it will be dealing with CSVs. This is important. And this second mandatory parameter is this streaming true. Okay, that's good. This is the first thing that needs to be done to make it working. Then we have start, stop. This is trivial. And two processors, transfer messages. Very simple. Again, the first one is taking the record from this CSV file, is reading just some of the fields, I think 5, 1, 2, 3, yeah, 5. So it's kind of narrowing the scope of the data, and it is creating a JSON object for it. What is important? Deferred true. Why is it important? It is important because having that, this stream will not be consumed in this transfer message, but it will be immediately passing through to this next transfer message, even if not the whole stream has been consumed. It's, again, like a flow. Yeah? So in this next transfer message processor, we have a sample of data enhancement. Trivial ones, because what this script does is just adding a new field to each JSON object. This field is called timestamp, and the value is just the current timestamp. Yeah? Normal in the real life, you would probably have some value from the external system, from the dictionary, anything. Yeah, this is the example, trivial example of enhancing the data. Again, this is the deferred true. So stream goes, once the first record is being processed, stream goes immediately to the write component, and it's being written back to the output folder. Is it started? Yes, it is. So let's start with the first exercise. I will go to the demo3 folder. Input is empty. Output is empty also. I will copy this very small, just for the sake of the presentation. Again, I need to add the breakpoint. Okay, it's been processed. Okay, what we have in a payload. As expected, this is what we would like to have, file input stream. It means that not all the data has been read yet. We are operating on the stream, which is good, Next. Okay. The type of the payload has changed after being processed by the first transformer, but it's still of a type stream. So this is still a stream, and we are operating on the stream. Next step, we are adding a new field here. We are writing on disk, stop. Okay, well, let's see what is the output of this exercise. Input folder is empty. Output contains a file that has an array of objects. For this type, for this exercise, we have just one object and a couple of fields taken directly from this. Sorry. So we have France, and the timestamp added. This is the example. This value is new, so it's been like added by us. So the data was enhanced. This is how it works. And now let's see what is the impact on the memory when we are processing large files. I will remove this. Let's now see. Oh, this is the good opportunity to show you what we had not before. Okay, this is the place when the MuleSoft runtime displays the PID of the Java process. So we need to look for it in the virtual VM. This is the one, starting with the 11. Okay. What we'll do, we delete this output. Okay, let's play 5 millions. It's okay. I would say quite a huge. I don't claim that this is a giant file, but for my laptop, 5 million of records, it's something. It's more than half a gigabyte of text data. I will copy it. And let's see what is happening here. Has it started processing? Let's see at the end of the log. What we have here, start. Okay, we have not stopped. It will take some time. Let's go to the visual VM. What we have here, as you can see, there are some peaks of the memory consumption because this huge amount of data needs to be processed. So even for the, I would say, current processing, MuleSoft needs some memory to operate. This is the CPU, which is now under work, I would say. But what is the most important thing we can see here immediately? The level, the general level of the memory consumption is under control. We are processing a giant file in a relatively small JVM. So if it was like this, that the whole data is being read for processing, we would end with out memory error for sure. Yeah? But it's not the case. We are doing the job. We are processing the data on the fly using those transfer messages, but we are still keeping the memory consumption in the reasonable level. So this is the, I would think, the interesting outcome of this exercise. Okay, I think it's finished right now. Yeah, it's stopped. It took us minute and a half, something like this. Let's see, the input file is empty, output file. Okay, it's greater because of the format. It contains almost 1 gigabyte of text. And this is the properly processed data together with this timestamp. But this is actually what is brilliant thing here. The level of the memory consumption is again at this, in the starting point, I would say. No additional memory consumed. Everything was used in the meantime, but then released. And this is what actually is, I would say, a good takeaway from this exercise. As I said, the file was quite huge. It was not impossible to read it entirely to the memory. Okay, I will stop it, and I will go back for the summary. here. Okay, right demo. I think, okay, let's summarize. So just quickly to let you memorize to remember those types of streams that are available. There are basically three. Non-repeatable streams is the simplest one. It has its limitation, can be read just once, but it's quite performant. No extra memory needed to process even the whole streams, the big streams, sorry. Repeatable in-memory streams, this is the first type of those repeatable. So they are creating some abstraction layer and covers the complexity behind us to make the stream more usable, but also with some drawbacks. This is the default for the, as I said, previously it was called Community Edition, now it's called Mule Kernel. Anyway, we know that it's not this Enterprise Edition. It has some defaults, but when we extend this max buffer size, as I showed at the demo, we end up with a failure. The third and the last type, file stored repeatable stream. This is in turn a default for a Mule Enterprise Edition. It is the one which uses the disk storage. Yeah? By default, it has some initial size for this in-memory buffer. Once we extend this memory buffer, we are starting serializing data on disk. This type of stream uses the cryo serializer, which performs and operates better than the standard Java serializer, but has also its small drawbacks. One of the final slides, I created this this picture because it somehow shows the position of those streams in the whole in this whole ecosystem. So on the horizontal axis, we have the factor of convenience and robustness. By robustness, I mean not throwing exceptions. And on the vertical axis, we have this performance and better optimization. So non-repeatable streams are definitely very performant, but they're not that convenience in the way that we need to remember and obey the limitations. On the other hand, we have this repeatable file store streams, which is quite convenient to use and is a default, but it might happen, it does not necessarily happen, but it might happen that because of this buffering and because of this I/O operations, which might be costly, it might perform slightly worse. And repeatable in-memory streams is something in the middle, between those two. Last slide, no. The slide before last slide. Performance considerations. Very shortly. Repeatable streams, which have been introduced in memory 4, are a good compromise between performance and convenience. It's not a coincidence that they have been set as default. For me personally, I think that most of the developers, including me, till, I don't know, a couple of months ago, I was even not aware about the existence of those three types. I was just unconsciously used this default, which was the on-disk repeatable stream. Yeah, and it is good for most of the cases. For some cases, when the data is large and it is suitable to be processed as a stream, as I mentioned, there are also some constraints like a type of the data, JSON, XML, CSV. We can definitely consider it. I'm not saying that we should definitely choose. We should consider non-repeatable streams for this kind of a processing. We might end up with a good performance. This point I added 2 hours ago before this presentation. I was hesitating if I should add it or not because I didn't want to make this presentation very lengthy. But we are almost at the end, so I will just make a couple of comments about the batch jobs, because for sure you've heard that the batch job is the most idiomatic solution for processing large files, for processing files with thousands of records or even millions. This is totally true. This is totally true. But the batch job is different in nature component. I mean, a batch job is very good for reliability. Why? Because in the first phase of the batch, as you probably know, batch step has 3 phases. It's this load and dispatch phase, then the process phase, and the summary phase. And this load and dispatch phase, which is the implicit one, so we don't have any options to influence it. In this phase, almost none. In this phase, the data is being read and stored in a persistent queue. Persistent queue. At the one hand, it is good because each record payload is split into records. It's stored in this persistent queue, and each and every record has its metadata related. One of the components of this metadata is the name of the last step in the batch job that has been successfully processed for this record. So even though we have some corruption, the MuleSoft runtime goes down for some reason, then because we have all the data stored in the persistent, I'm emphasizing it, persistent data queue, persistent queue, we can resume the processing exactly from the point when it stopped. Because we have everything, we have the current state of the record and we have a metadata related. Okay, but what it means to read the whole data to the persistent queue. Okay, now we have 2 choices. When we are on-prem, this persistent queue is stored on disk. Okay, there are some I/O operations related. If we go to the Cloud Hub, there are again 2 options. If this magic persistence queue checkbox is not selected, the persistent, as far as I remember from my examination, the data will be stored on the local disk storage of this worker. But if you have in this worker in the Cloud Hub, but if you have this checkbox persistent queue selected as true, then the data is stored in the Maven SQS. What it means? Network calls. So at the end, we can end up with a situation when there will be a lot of I/O operations being done to process this whole set of records. It might be costly. Even this initial process might be costly, like the loading the data. Of course, when it comes to this process part, we have some ways to optimize, like the block size, for example. So we can read records in blocks to save some I/O operations. But I'm making a stop here. I just wanted to say that it all depends on the requirements, the current situations, the limitations, the resources available. All of it, the architect should know, should discover, and should make a conscious decision. What architecture would be the best for the solution? Sometimes it might be that the architect will choose streaming. Sometimes he will choose batch jobs. It depends. Yeah, they are different, but still, batch jobs is of course a good solution for processing large data. Last comment: when you decide to use non-repeatable streams, you need to ensure, and I'm constantly repeating about those limitations. The input stream can be read just once. It cannot be read simultaneously. It becomes an issue that needs to be addressed. It can be addressed with the data weave and this deferred mode, as I presented, but you have to use it carefully, consciously, and know the limitations. Last slide, very last slide of this presentation, and probably it might be the most valuable takeaway, because it's quite frequently omitted for some reasons. Conduct proper performance testing before going to prod. Please do, please do. Even in the initial phase, when you are doing proof of concept, please do a performance testing, because once you start with some design, with a small amount of data, and this design will work, you may end up at the end on prod with a high volume of data, and this solution would not be that perfect anymore. So the earlier you do performance testing, the better ending it would be. Yeah, this is my last comment. Thank you for the listening, and I'm passing the ball back to Patrick.
Thanks, Jacek, but it's not over yet. Still, we've got. I think we've got 3 questions in the Q&A asked for you. But before, you know what is happening. You know what's happening. I will quickly before I will randomly select the third winner for Amazon voucher for 30 bucks. This is 31. Who is number 31? To whom it will go? Let's skip it. 31. And the voucher goes to Jayant Gorinta. Yeah, congrats. Your voucher is yours. Just ping me your email on the direct message. So yeah, big congrats. I like this moment. But in the meantime, we've got, I'm not sure, Jacek, if you can see the Q&A section, or I need to share it to you.
Sorry, Q&A section. You're not sharing.
You can
anything.
see. I'm not sharing? Oh,
yeah, yes,
okay.
yes, you do. Sorry, you do.
Yeah, there is next to the general where is the chat. Yeah, there is a Q&A section, and I see the question. I'd like to stop sharing for a moment just to send a message. Do you see it at your screen? I bet you do.
Q&A, yes.
Yeah, so let's maybe go through them. As I see, some of them may be interesting. So all the questions are interesting, not some of them. What the benefits of streaming if we have batch? Actually, I think that you were answering this question a moment ago. Yeah, when you described the batch stuff. But the second part, I think, was not answered. Can file stream, repeatable stream be used for or API deployed on-prem or also on Cloud Hub, as it's using a disk store?
Sorry, because I'm a little bit lost. Am I expected to answer those questions? Sorry.
Yeah, that was question to you. Yes. Yeah.
Okay, questions. What is the okay? Because I was a little bit unfocused after the presentation. Okay, so there are some questions I'm expected to answer.
Yeah, please.
What is the benefit of streaming if we have batch processes for the same? I think I answered this question. Yeah, I answered. These are 2 solutions that both are possible. They have some differences between. Can files stored repeatable stream be used only for APIs deployed on-prem or also on Cloud Hub, as it is using this? It can be used in both places, definitely. As I said, on Cloud Hub, there is also access to the disk space. Yes, we have some limit, of course. It depends on the vCores, but yes, answer is yes. Why did the demo tool with 124 megabyte file while writing? Why not while reading? I think it might be the reading in the background might still be happening. Probably this is the answer, but precisely I don't know. I would need to deep into it to go into it deeper. Yeah. So this was those 3 questions.
Great, thanks. For a moment, I was worrying as my keyboard stopped working, and I could not even. I will be. I could not copy the email that was shared with me. That was very interesting. But right now, you should see my screen. Yeah, can you see it? Yes. No. I want to be sure before I will start presenting.
Yes, I can.
Yes, great. So we are moving to the next part. Tree. Oh, what is it? Okay. Well, we've got trivia quiz. As I said at the beginning, the rules are plain and simple. The questions are around the topic that was discussed today. So if you were listening, Jacek, carefully, then you are good to go. Yeah, you are good to participate in this quiz. There are 3 winners, and each of the three top winners will receive voucher for any MuleSoft training. So that's kind of nice. You can attend the training, for example, that Jacek was mentioning at the beginning for integration architect. So we've got here 3. Remember the rules. You need to answer correctly, obviously, but the quicker you do, the better, as more points you earn. So try to do it as quickly as possible, and yeah, there's a fair chance of winning. We will be using today Menti tool, and I will quickly present the view. Please visit on your mobile device or on PC the webpage www.menti.com and type there this code 91556397 and you will instantly join us. So I see something is happening. I will just hide it. Okay. To start countdown. I can move to the next. Is it a question? Oh, oof. Okay. I was not using this for a quiet, so I didn't remember if I can safely go to this web page. Okay, so we've got 5 questions. 5 questions. So for all of them are based on today's presentation. I see many of you are coming. 25. Who gives more? We've got plenty of you. I saw the attendance list. Don't be shy. Each and every one of you can win. There is a fair chance to do it. Yeah. I like in this Menti they are randomly picking those user emojis. Kind of fun. I'm waiting if someone will be a mule. Not sure. I see a rabbit. Okay, anyone else is joining? Let's give it a moment. Someone left. Someone left. Okay. Last a couple of seconds, just as not to stay here on this webpage too long. Okay, 5, 3. Oh, I'm counting terribly. Okay, I think that we are ready to go. Yeah, last chance, and I'm hitting enter, and you will see the question. Anyone else? Oh, I like the gold. Oh, amazing. Okay, I think we are good to go.
That flag is a bad position against that goat.
Oh my God, Martin, you're so right. Oh, and the goat missed. Oh, okay.
Immediate feedback.
Immediate, and the goat goes more on the second side. Okay, let's hit enter. Let's see. Answer fast as possible. One answer is correct. What is a valid statement for non-repeatable streams? Is it cannot be processed by data with, can be read by multiple threads simultaneously, or can it be read, consumed only once? What is valid? We've got plenty of time to think this over. What is valid for non-repeatable streams? Jacek was repeating it repeatable many times. Okay, fair. 25 of you answered correctly, so it can be read only once. So this is its characteristic. Yeah, good. Let's move. We will see right now the leaderboard, how it looks. The leaderboard, I mean, what are the scores at the moment? But if you are not here or do not see that, do not worry. It's rapidly changing as everything can happen as you are answering as quickly as possible. So let's move to the next question. Question 2. So the validation that checks if data with script complies all stream processing rules is called stream valid, stream capable, or stream correct. Which one of them? Oh, we've finished before the time. Nice. So 20 of you, yeah, correctly is stream capable. Quite interesting function. Let's me hit enter no, this dash. We will see the leader dashboard. As you may see, their points are counted. And some changes on the dashboard. Okay, 3 more questions to go. Don't worry. Which data format is not supported by data with streaming? XSLT, JSON, or XML? Which one of them is not supported? Yes, I like it. Every one of you answered correctly. Yes, amazing. I like it. But the quicker earned more points. 2 more questions. Stay tuned. Which serializer is used internally by file store repeatable stream? Standard Java serializer, Cryo serializer, or Magic serializer? Which one is used? Jacek, by the way, did I spell it correctly? Cryo?
Right.
Yeah.
Cryo.
Cryo. Okay. I'm not sure how I would pronounce it. Corrijo, if you would not tell it before. Okay. Most of you answered this correctly. So you were looking carefully at Jacek's presentation. And there is one last question. Let's see about that. That will be a big surprise for some of you if you were not attending from the beginning. Question 5, the last one, the tricky one. When is happening this year TDX 22 conference? Is it April, May, or December? When it is happening? I was telling this at the beginning. I hope you catch that. Yeah, it's happening April 27, 28, which I encourage you to visit either online or in place. Yeah, good. So that was all. And right now, when I hit the next button, we will see the winners. I'm so excited. I always love this part when we see who won, like in the Hunger Games. Hmm. Let's see. Okay, congrats. Of course, I do not know who are you. I will just make a screenshot and please send me the direct message right now. You, Yatin, Garag, and the third, David. So please just ping me over the chat that you are who you are, and you are the lucky winners of Amazon, not Amazon, MuleSoft vouchers, and yeah, congrats again. That's nice. Let's move to the presentation. So congrats again. I will be sending forms for all of you for MuleSoft voucher winners tomorrow. And let's do the wrap up. Can I start the presentation from this slide? Prezentacja na żywo. Nie, no, that's not that case. I think I broke my presentation. Relacja. Okay. Oh, here it's over. Okay. Of course, I'd like to thank Jacek for being a volunteer and sharing his knowledge and experience that's gained during the last couple of months related to the streaming stuff. And I hope you do the likewise. We are in the MuleSoft community. We are sharing our experience, knowledge freely. As you know, there is happening loads of MuleSoft meetups, and I encourage you to share your knowledge, share your experience, share your ideas on our Warsaw MuleSoft meetup. Just reach me. Feel free to reach me over on the LinkedIn or the email that I'm just pasting here as well. And yeah, one stuff, you don't need to be super fluent in English. You can hear it. I'm not, and I hope it's not a problem, but it should not stop you. And you do not need to be a super expert. You can share your experience, what you've gained. You do not need to be a super all wise man with all the 100% answers for the topic or idea. You can say, you can show us, tell us what you've learned by by doing deep dive in some area of the MuleSoft. So feel free to do it. I encourage you to. And any MuleSoft speaker is having as well MuleSoft voucher for any training she likes. So that's as well fair stuff. And that's all from my presentation. So I'll stop it. And yeah, we've got, I think, a moment in between before I get the voucher winners emails. How did you like the Jacek's presentation? Give us some feedback. I know we like it.
I was trying to do my best.
Oh, you do. I like the presentation. I like the topic as I do not find many good materials around it. I must say, yeah. So that's valuable. Yeah, nothing else. I think that's it. And I thank you very much for joining today for our presentation. And again, thank Jacek for your contribution. Thanks, Jacek, again, and thanks all the attendees. Take care. Bye. Bye-bye.
Thank
Bye
you.
bye,
See you.
guys.
See you. Bye.